study the initial value problems of higher order. We have done first order linear differential equation, and now we will study the higher order differential equations. For that we will study the initial value problem, and initial value problem is basically for the conditions that has initial conditions. So first of all we will study what is the nth order differential equation. Nth order differential equation is, now we are concerned with the higher order differential equation. So nth order differential equation is the coefficient an along with the nth derivative plus this coefficient. This is a function of independent variable like this x d n minus 1 y by d x n minus 1 to so on a2 of x, basically d2 of y dx square plus a1 first derivative plus a naught into y equals to g of x. Now this equation is the nth order differential equation, and it is linear with three conditions. First condition is that all these coefficients an minus 1, a2, a1, a naught must be the function of independent variable x. Second condition is that all the y and y derivatives must be of degree 1. You can definitely see that y has the degree 1, first derivative has the degree power 1, second order has the degree 1, and this has the degree 1. This is all its derivatives should be of degree 1. And third condition is additional condition for non-homogeneous equation. If it is a homogeneous equation, then you don't need to check that g of x, because this right hand side is 0, and if it is not 0, then you have to check that this forcing term must be the function of an independent variable. So these are three conditions to check the linearity or linear differential equation. Okay, now we are checking that whether it is an initial value problem and how to check the solution of uniqueness of a solution of initial value problem. So this differential equation becomes an initial value problem if we have these initial conditions. So initial conditions of these differential equations are, this is basically I am writing subject to. So it starts from here, y of x naught is a constant point, equals to y naught, y dash first derivative of x naught equals to y naught dash, this is also a constant, and also to so on. Y last condition is y of x naught, and that is last condition is derivative is n minus 1 equals to y naught of n minus 1. So these conditions are called initial conditions, and this problem as a whole along with the differential equation is called initial value problem. Now we will check now that whether the solution, what is the condition for the existence of its solution and the uniqueness of its solution. So existence and uniqueness of this type of solution, existence of a unique. So first condition is that check that all these coefficient functions an minus 1 and all a2, a1, a naught, so all I'm writing it a naught, a1, a2 to so on an minus 1 an and plus, okay, and that means and g of x are continuous. You have to check that these all functions of x or constants are continuous along with the g of x. So this is the first condition. And second condition is that the leading coefficient, check the leading coefficient. If it is nth order differential equation, the leading coefficient is that coefficient that is multiplied by the highest derivative, right? So highest derivative here is n, so along with that coefficient an is the leading coefficient here, so an should not be equal to 0. So these two conditions, check these two conditions. If in any initial value problem these two conditions are met, then that means solution exists and that solution is unique and unique. Okay, here is the example of second order differential equation that says that y double dash minus 4y equals to 12x. So y double dash means second order derivative. Now we can check that whether its solution exists. These are two initial conditions. This is y of 0 equals to 4 and that is y dash of 0 equals to 1. Remember always that if you have second order differential equation, the initial condition must be one less than this first order initial condition. Simply if you have third order differential equation, then initial condition must be up to second order differential equation. So in the standard form or in general form, if you have nth order differential equation, then initial condition must be up to n minus 1. So this is the rule for initial conditions to solve any kind of equation, differential equation. Now we check that whether its solution exists or not, or it is unique or not. So first of all, leading coefficients, we have to check that what are the leading coefficients. So we start with a naught along with the y, that is minus 4, okay, constant, continuous. And then a1 there is no first derivative, so a1 is 0 and a2 is here the leading coefficient and that is 1. So all of these three are continuous, plus g of x. G of x here is 12x. Alright, so first condition is that these all are continuous and the leading coefficient a2 is equal to 1, that is not equal to 0. So second condition is also met, first condition is also met, so that means solution exists and is unique, right? Okay, second example. Here is the second example. Okay, second example says that it is 3y triple dash means third order derivative, plus 5y double dash minus y dash plus 7y equals to 0. So highest derivative is third order. So here we identify the coefficients and the forcing term g of x, and such that y of 1 equals to 0, y dash of 1 equals to 0, y double dash of 1 equals to 0. So if it is a third order, then we write it up to second order initial condition is mentioned. So first of all, we start with a naught. A naught equals to, let me do this, arrange this. Okay, a naught equals to 7. All right. And a1 equals to minus 1 first derivative, a2 equals to second order derivative has coefficient 5, a3 equals to 3 and g of x equals to 0. Yes, it is 0. So first condition is all of these are constants and is continuous function. Alright, Second condition is that the leading coefficient here is A3 and it should not be equal to 0. So that means solution exists and is unique, right? Okay. In the next example, example number 3, here, okay, y double dash plus 16y equals to 0 such that y of 0 equals to 0 and y dash of 0 equals to 1. Second order, check the coefficients. A0 along with the y, A0 is 16, A1 there is no first order derivative, so A1 is 0, A2 is 1, g of x is 0, so all of these are continuous, and continuous means that there is no point of discontinuity, and you know that discontinuous point is that if you have anything in denominator like 1 over x minus 1, then it is discontinuous at 1. So 1 over 1 minus 0, 1 over 0, so that is not defined here. So there discontinuity can arise, but in these constants there is no point of discontinuity here. Okay, and leading coefficient here in this example is A2, and A2 is not equal to 0, that is equal to 1. So that means solution exists and is unique. Alright, so I hope that you understand this initial value problem, and simply by looking at the differential equation, higher order differential equation, you can say that its solution exists or not by simply having this theorem, the existence of a unique solution.